Okay, so then once you get done turning in your cotangent, cosecant graphs, we'll be we'll just be straight up noting or out of notes then today. Nothing special. We'll be doing some graphs, but you can just do some sketching today. Because today we're going to start talking about the inverse sine function. Now, in order to start talking about the inverse sine function, the first thing that we got to talk about is the inverse aspect of it. Okay? And so we have to remember back to when you were in Algebra 2 or Algebra 2 Extended, what we do to find an inverse. Okay? And finding an inverse is pretty easy at the start, but then it gets a little more complicated right away in the first step. Okay? So an inverse function is a function where if you make the composition of the two functions, so if f and g are inverse functions of one another, then f of g of x would be the same as g of f of x, and that would be x. The functions basically cancel each other out. And that's what an inverse is. Now, to go about finding that inverse, it's actually, like I just said, relatively easy. All you do is, if you're given the function, for instance, y equals 3x, if you're given that function, you just switch x and y. Leave everything else the same. Just literally take where x is in that function and put it where y was. And where y is, you put x. And you just switch the spots. So for instance, in this one, it would be if y equals 3x, if I switch them, then it would be x equals 3y. I've just taken x and y and flip-flopped them. Okay? And then to make it be back into function notation, we would then solve that for y. So if I solve this equation for y, y equals x divided by 3. So these two equations are inverses. Now, if this were yesterday, we would have gone through all of the rest of these, and we would have really honed in that inverse thing. Okay? But because it's today and we're on a little bit of time crunch, because we only got 2 months instead of 3, we're going to skip right down to the good. Y equals sine x. So if I flip-flop my x and my y, then that becomes x equals the sine of y. And here now is where it gets all kinds of funky trying to solve that for y. Okay? Because now if I solve that for y, I get y equals the inverse sine of x. So let's talk about that inverse sine function. Remembering the fact that to find inverses, we switch x and y. Okay? So if I said, graph me the sine function, this is what we ended first semester with, graphing the sine function. Okay? Talk to me first wave, second wave, negative first wave, what would the graph of the sine of x look like? Give me first wave. Where does it start? Middle, okay? Then up or down? Up, middle, down, middle, right? Okay? And that would be starting at 0 or at 1? Y value? 0, right? Okay? All right? So it looks like this. Right? And that goes on forever and ever and ever and ever, right? Always looking like that. Yeah? Okay. So some key points here. It goes through 0, 0. Yes? Okay? What is the coordinates of that point up there? Not 1, 1. Pi over 2, 1. Yep. This one. This one. This one. Okay. This one. Negative pi over 2. Yep. So they're always going on those. This one. And this one, last one. Okay. Okay. Now, again, to find the inverse, what do we do? Flip what? Flip the x and the y. Okay? So if I want to graph the inverse of sine, what, give me a point that it would go? That the inverse would go. Okay, all I do to find the inverse is flip the x and the y. Give me a point that the inverse sine goes through 0, 0. Yes. Give me another one. 1, pi over 2. Give me another one. 0, pi. Give me another one. See what we're doing there? What are we just doing? We're just flipping the x and the y, right? And that works within the function notation like we did in the last slide. That works off of the graph with points. You literally change positions of x and y. Okay? So with that being said, then, my inverse function okay, it would go through the point 0, 0. Then you said that it went through the point 1, pi over 2. Oops, I made my pi in a bad spot. Then you said it went through the point 0, pi. Then you said it went through the point -1, 3 pi over 2. If we go the other way, it would go through the point -1, comma, negative pi over 2. 0, comma, negative pi. One, comma, negative 3 pi over 2. So that this, then, if I connect the dots, would be my function. What's the problem? What's the problem with what I just said? This would be my one. Why is it not a function? What's the one test for a function? Vertical line test. Does it pass the vertical line test? No. So it's not a function. That's the downfall. And you guys had that back in when we were first learning trig. And we said, when we went to the unit circle, we said, yeah, right here at pi over 3, the sign is 3 pi over 2, right? But that's not the only spot where the sign is 3 pi over 2. There's also at 2 pi over 3. There's also at 7 pi over 3. There's also at 8 pi over 3. There's also at 13 pi over 3. There's also at 14 pi over 3. And all those different ones. Okay? Not a function. A function would give us one value for that one spot, nowhere else. Okay? So the problem that we have here then is we have to do some restrictions to the inverse sine function. Okay? So first off, we're going to learn some notation for the inverse sine function. The first one is, you've already seen it, you probably used it, you learned it back in geometry when you had to find an angle. Okay? Inverse sine. Okay? The new one today is also arc sine. Arc sine and inverse sine are reason. So because of that repetitiveness of the sine, cosine, tangent functions, we need to figure out where we're going to find our answers. Because what we're going to use this for is we're going to say inverse sine of 1/2 is something. Okay? You're going to find that angle. Inverse trig function, find angle. That hasn't changed from geometry. Okay? So, what I'm going to do is, you already have this on your graph. Let's see if I can paste, there it is. Okay, so there is my function, or my inverse function, quote unquote, my inverse relation. We need to have all of the values between -1 and positive. Because that's where sine lives, right? Sine doesn't live outside of that -1 to +1 range. Okay? which means we want -1 to be less than or equal to the sine of theta is less than or equal to positive. Okay. So we need to be between 1 and -1 and +1. So we could go right here, right? That would give us all x values between -1 and +1, right? Is that the easiest one? Probably not. Okay. We could go here. Still not easy. Let's go with the easy one. And the easiest one is, tap the brakes. Let's go with that one right there. We have all of the x values from -1 to +1. Yep. Okay. We started at would have been a low or a high, depending upon where we were at, ended at the other one. Okay. So this, by limiting that 1, am I a function now? Yeah. By just taking that section of the inverse sine graph, I am now a function. Okay? Or this is now a function, I should say. Okay. So this would give me, so my input values into the inverse would be between -1 and +1, right? My output, the angles that I'm looking for, what would my angle measurements be? What would the output of this function be? So the input was x values, right? What would my outputs be? Or what would the range of my outputs be? You think? Nope. So my output would be between -π/2 and +π/2. These values right there. Okay. Now, where is that? Where on the unit circle is the output values, the angles, if you will, -π/2 to +π/2? It is. Okay, so give me a side of the unit circle. So the right half of the unit circle, right? Yeah, okay. Because I can't say, the way you said it, between 90 and 270 would be left half. You know what I mean? So that's what, so we would go from 90 to -90 if we're talking degrees. Okay? Right? So this is, ladies and gentlemen, the right half of the unit circle. Now I'm I'm going to tell you this, and we're going to do one, maybe two examples of it, and we'll pick up more of it on Tuesday. Okay? Your answers. So inverses find angles, right? Okay? So all of your angles, excuse me, have to be in between negative pi over 2 and positive pi over 2. If they're outside of that range, you are wrong. Okay? Right? Easy there, Siri. What I mean by that is, okay? So now we're looking at the unit circle. Arc sine is 1/2. Okay? Where on the right half of the unit circle is sine 1/2. Right half of the unit circle, where is sine positive 1/2? Pi over 6? Okay. Does pi over 6 fall in my negative pi over 2 to positive pi over 2 range? Yep, it does. So this answer here is pi over 6. Okay. Tweak it. Arc sine or inverse sine, they are interchangeable. Saying to myself, self, where on the right half of the unit circle is the sine value negative 1/2? You want to say 11 pi over 6, right? Why is it not right? What's wrong with 11 pi over 6? So if we take the pi out of it, 11 divided by 6 is how much? Almost 2, right? Okay. If we take the pi out of the range of values that we can be, our range of values has to be in between negative 1/2 and positive 1/2. Is almost 2 in that range? No. So we can't say 11 pi over 6. So what do we have to say instead? Negative pi over 6. Yeah. We got to say negative. And that, ladies and gentlemen, is a great place to pause for the class today. Okay? We'll pick up on this again on Tuesday. We'll deal with inverse cosine on Tuesday, and then we'll start getting into inverse tangents and compositions of functions on Tuesday. Okay? Still tentatively looking at a formative, but that formative now might be on Friday of next week instead of Thursday, as discussed.